In this video, we are going to look at unit conversions. Remember, units are multiplied, divided, and canceled out just like any other algebraic quantity. We use units as a guide when we're solving problems, and this is called dimensional analysis. Remember to always write every number with its associated unit. Do not just write a number by itself because that does not give us enough information about what we are describing. Always include units in your calculations. When you're dividing them and multiplying, we use them as if they were algebraic quantities. Also, do not let your units disappear or just randomly appear during your calculations. Always make sure to keep track of your units. So when we are doing our conversions with our units, we have to think about what we are given and what we are looking for, and also how we can come up with relationships that we can use to accomplish our conversion. Then when you set up the problem, always check your answer to make sure all the units canceled out correctly. If your units did not cancel out correctly, you may have made a mistake during the course of your calculations, and then you should go back and find where the units did not cancel out properly. For most conversion problems, we are given a quantity in some units and asked to convert it into a quantity of another unit. These calculations take the form of our information given times our conversion factor gives us our information sought. So when we write it out in chemistry, we'd write out our given unit multiplied by the conversion factor, where the given unit that we start with will cancel out with the bottom unit on our conversion factor. This leaves just your desired unit left. For example, if we wanted to convert centimeters into inches, we have a conversion factor. Our conversion factor is 1 inch equals 2.5 centimeters. So if we were to try and write this calculation, we can write out this conversion factor as one of two ways. There'd be 1 inch on the top and 2.5 centimeters on the bottom. Or we can write it as 2.54 centimeters on the top and 1 inch on the bottom. Either way, it's the same conversion factor. You're just flipping which side the unit is on. So we can look at a problem of how many centimeters are in 6 inches. 6 inches is our given unit. So we start with our given unit, and then we'd multiply it by our conversion factor. Now, since we start with a given unit, we want the inches to be on the bottom. So we are going to use this form of the conversion factor. So we have 2.54 centimeters divided by 1 inch. This gives us a quantity of 15.24 centimeters. We can see our inches cancel out, leaving us with just centimeters as our desired unit. So a couple more examples on problems like this. Let's say we want to convert 0.1350 meters into inches. Now, unless you can remember what the conversion factors for meters to inches is, you'd have to do this in more than one step. So if we want to do it in more than one step, we have to think about what we start with. That's 0.135 meters. And then think about what conversion factors we have that can accomplish our conversion to inches. We already know from our previous slide that I have 2.54 centimeters equals 1 inch. And then we've also learned how to convert between meters to centimeters. So I also know that I have 100 centimeters equals 1 meter. So you can see centimeters is our common unit here. So what we're going to do is we're going to use that common unit to help us bridge the gap between meters to inches. So we'll put our common unit on top and our starting unit on the bottom. So this way our meters will cancel out. Then we're going to put our desired unit of inches on the top and our common unit on the bottom. Doing it this way, the centimeters will cancel out as well, leaving us with just a desired unit of inches, giving us an answer of 5.315 So now sometimes you might also run into problems like our second one here, where we start with 2 units and we end with 2 different units. We want to convert 55 miles per hour into meters per second. Something like this might be kind of daunting, but we can break it apart. So we can see the top units are units of distance or units of length of miles and meters. So we can work on converting miles into meters. We can also convert hours into seconds. So the bottom one are both units of time. So we can start by first converting the top from miles to meters and then converting the bottom from hours to seconds. So if we start with 55 miles per hour, and I also know that 1 kilometer is 0.62 miles. So now my miles will cancel and I'm in kilometers per hour. So you see how we just carry the units across that way. Now I'm going to go from kilometers into meters. So I know that for every 1,000 meters, I have 1 kilometer. So now you can see we're in our desired unit for our measurement of length. So now we just need to convert our hours into seconds. So I know that for every 1 hour, I have 60 minutes. So this way my hours will cancel. And now we're in meters per minute. I also know that for every 1 minute, I have 60 seconds. So now your minutes will cancel, leaving you with just your desired units of meter and second. Everything else here cancels out. And this gives us 24 meters per second. So you see, even with longer ones, if you just break it apart, it becomes easier to solve. So now you should be able to work on your unit conversions and be able to solve your problems.